Hello, I'm Mr. French. I'm coming to you from my classroom in Mount Pleasant, Utah, and this is topic 3.2 Implicit Differentiation, some examples from the AP Calculus AP Classroom curriculum. So here are some examples of how to work with implicit differentiation. Our first example is 4x cubed plus 2x squared y cubed equals 3y. All right, and I want to find dy dx. So the first thing I notice is that I have two terms that contain y's. So as a check through the process, after my first differentiation pass, I should have two terms with a derivative of y, or an f prime. I'm going to start by replacing my y's with f of x. So this will first be 4x cubed plus 2x squared f of x cubed. This is optional, but I've always found that it helps to remind me that I am taking a derivative that's probably going to require some chain rule. And the derivative of y has to be acknowledged as I go through the process. So our first term, 4x cubed, straight power rule with a constant multiple. So the derivative of 4x cubed is just 12x squared. The second term here, 2x squared times f of x cubed, that times 2x squared times f of x cubed implies a product rule opportunity. So I'll take my first term, 2x squared, and multiply that times the derivative of my second term, f of x cubed, which is going to require a chain rule. So I'll take the derivative of the outside operation, raised to the third, bring down the 3, leave the inside alone. With my new exponent, 3 minus 1 is 2, times the derivative of the inside. Derivative of f of x will be f prime of x, plus my second term, f of x cubed, times the derivative of my first term. Derivative of 2x squared is going to be 4x by the power rule. And that's going to equal the derivative of my right-hand side. Well, 3 times the derivative of f of x, which is f prime of x. So here's where I go back and I check. I had two terms with y's in my original expression, and I have two derivatives of f of x or y, f prime. All right, now the same steps to find my derivative that I will always have in an implicit differentiation. I'm going to group my f prime or y prime terms on the left side. So I will have 2x squared times 3 f of x squared times f prime of x. And I'm going to subtract the 3 f prime of x from the right-hand side. Set this equal to the non f prime term, so a negative 12x squared, because I moved it from the left side to the right side, minus 4x f prime of x cubed. At this point, it might be easier to work with y's instead of f of x's, so I'll go back and replace my function with y's. So this becomes 6x squared y squared. The f of x is a y now, and I combine the 2 and the 3. Y prime minus 3y prime. The f prime of x is the same as y prime. Minus 12x squared on the right, minus 4xy cubed. The f of x is now a y. Our last two steps, after I've grouped my y prime terms, I can factor out a y prime. That's going to be 6x squared y squared minus 3. And that's going to equal negative 12x squared minus 4x y cubed. Finally, the last step would be to divide, and I would get y prime is equal to my negative 12x squared minus 4xy cubed, all divided by 6x squared y squared minus 3. And there's my derivative, y prime. Let's look at another example. All right, here y is the natural log of 2y cubed minus 4x squared. Once again, I'd start by saying I have two places where I have a y, so I should have two terms with a derivative of y after I've taken my first pass through with the differentiation process. So we will start by replacing my y's with f of x's. F of x equals the natural log of 2 f of x cubed minus 4x squared. And we start by taking the derivative. Derivative of the left side, derivative of f of x is f prime of x. The derivative of the natural log of something, using the chain rule, would be 1 over the something, the derivative of 1 over the inside of the natural log. So 2 f of x cubed minus 4x squared. Don't touch that. But then I multiply by the derivative of that expression, the derivative of the inside of the natural log. So here, the first term is 2 f of x cubed. I'm going to apply the chain rule here and the power rule. Bring down the 3, and I get 6 f of x squared because I leave the inside alone, but then I multiply by the derivative of the inside. And then minus the derivative of the second term, which is just 8x. Okay. From here, we need to do what we've done in the past and isolate our f prime of x. I'm going to do that by creating, first I'm going to pull out the denominator. I'm going to multiply both sides by the denominator so that I don't have to deal with fractions. I'm going to put the 2 f of x cubed minus 4x squared from the denominator, multiplying both sides by the denominator. So now I have that number or expression times f prime of x on the left, and that's going to equal 6 f of x squared f prime of x minus 8x. The next step is where I group my f prime of x's on the left, which means I have to subtract this term here and move it over to the left. So now I have 2 f of x cubed minus 4x squared, all of that multiplied by 1 f prime of x, and then I subtract this 6 f of x squared f prime of x, because I moved it over from the right-hand side, equals negative 8x. Here it might be better to replace my f of x's with y's again. So now I've got 2y cubed minus 4x squared y prime minus 6y squared y prime equals negative 8x. The next thing I'm going to do is factor out the y prime from the terms on the left-hand side. So this becomes y prime times 2y cubed minus 4x squared minus 6y squared equals negative 8x. And our last step is to divide. So I get y prime is equal to negative 8x over 2y cubed minus 4x squared minus 6y squared. And there I have my derivative with x's and y's in my expression for y prime. One last example. If e to the y cubed minus e to the y equals x squared minus 4x cubed, then dy dx is going to equal what? Well, let's do this one without the f of x's, but remembering that whenever I take the derivative of a y expression, there should be a y prime as part of the derivative. So the derivative of e to the something is e to the something, e to the y cubed, times the derivative of the something. And the derivative of y cubed would be 3y squared y prime by the chain rule, minus derivative of e to the y, which would be e to the y times the derivative of y prime. And that's going to equal the derivative of the right-hand side. Derivative of x squared is 2x minus the derivative of 4x cubed, which is going to be 12x squared by the power rule. Okay, so my y prime terms are already grouped on the left-hand side. So I'm going to factor out the y prime, and I'll get e to the y cubed times 3y squared minus e to the y is equal to 2x minus 12x squared. From there, I can divide, right? Y prime is going to be equal to 2x minus 12x squared over 3y squared e to the y cubed minus e to the y. And there's my derivative. So if we review quickly, we take our derivative, making sure that for every term that had a y in the original expression, there is a y prime in my derivative. I group my y primes on one side of the equal sign and my non-y prime terms on the other side of the equal sign, so which allows me to factor out a y prime. And finally, I divide so that I can isolate my y prime. There we go.